Thank you for joining us. Today, our Senior Research and Development Chemist, Joe Stoller, and I will discuss how to make sure your engineers have the tools they need to maximize your supplier partnerships. I will start out by telling you a little bit about Epic Resins. Epic is located in southeast Wisconsin. We have been a custom formulator and manufacturer of epoxy and polyurethane materials since 1958. With 65 years of formulating experience, we have a profound understanding that not every application is the same. Our experienced team of chemists can formulate or adjust our current products to meet your application requirements. We minimize your investment risk by testing all products to the highest standards. Our production and warehouse facility includes approximately 85,000 square feet. This houses over 10 high-speed dispersers, multiple vacuum pumps, and our farm of raw material bulk tanks. Epic's core chemistries are epoxy and polyurethane thermoset materials. We have well over 3,000 epoxy and polyurethane formulas and service over 1,500 customers worldwide in 6 continents. Epic Resins is ISO 9001 and 14001 certified. Epic Resins has provided proven thermal management solutions for over 60 years. Our products for e-mobility provide solutions for many applications, including motor, battery, transmission, sensors, and ECUs. Now let's take a look at current challenges in the e-mobility market. As many of us know, our engineering teams tend to become overstretched. Epic Resins has invested in a copious amount of instrumentation that allows us to assist your team when bringing a product to market. We are able to complete verification testing in conjunction with your team, resulting in shorter time to market, creating a more cost-efficient solution. Onshoring has become more prevalent for various reasons, such as the European energy crisis, global COVID policies, and the Ukrainian war. Evaluating your supply options during the onshoring process is fundamental in your success. Epic Resins is able to evaluate and adapt to the ever-changing supply chain by adjusting our chemistries to continue formulating with the highest of quality, most cost-efficient raw material base. Selecting a supplier can be a daunting process. Epic Resins aims to become an extension of our customer's engineering team. We partner with your team to deploy our knowledge, experience, and instrumentation to assist in bringing the highest quality product to market. Now I will hand it over to Joe to take a more in-depth look at our instrumentation.
Thank you, Stephen. Myself and our experienced team of chemists can formulate or adjust current products to meet your application requirements. We do this by utilizing our next-level laboratory, which includes FTIR, MALDI mass spectrometer, NMR, TCI thermal conductivity analyzer, HR30 TA rheometer, thermal chamber, DSC, TMA, Instron, HiPot, and other electrical testing equipment. All testing is done in-house on our equipment to ASTM standards. Epic Resins has one of the most diverse and well-equipped polymer analysis labs in the industry. Within our lab, our customers have discovered and utilized several pieces of instrumentation that have added tremendous value to their partnership with Epic Resins. These key pieces of instrumentation empower our engineering partners to drastically reduce their workload and shorten time to market. This presentation will focus on 3 pieces of instrumentation. 1, using a rheometer to model process characterization of their potting material. 2, utilizing our thermal chamber for life testing to simulate validation testing. 3, conducting FTIR analysis for post-potting quality and stability. You will find that each of these sections yields vital data for your development, implementation, and longevity in using thermoset potting compounds. First, we will discuss how a rheometer can help to model the processing of your potting compound. One of the first questions we address for our customers in a potting application is how to implement the use of the potting compound. We help the customer address common questions like, will this flow properly in my part? How long will the material flow? How long before we can move the potted units? And how can we speed up our process? All these questions can be answered using a rheometer. First, what is a rheometer? A rheometer is an instrument that simultaneously measures both the flow and deformation of materials. During the curing process of a thermoset, these fluid and elastic properties are dynamic, making a rheometer key to the characterization of the curing polymer. More specifically, we look to analyze 2 main properties as the thermoset cures: the storage modulus and loss modulus. The loss modulus is the measure of the fluid properties of the material, versus the storage modulus is the measure of the polymer or elastic properties of the material. In this graph, you see the quantitative analysis of the loss and storage modulus of a curing thermoset. As the two-component thermoset begins to react, you can see that both the loss and storage modulus increase. They will both continue to increase until they reach what we call the crossover point. At this point, the elastic properties overtake the fluid properties, and we relate this to the no flow point in the reaction. This quantitative data is important because it shows three key pieces of information. 1. Optimum flow time of the thermoset. 2. Peak storage modulus build. 3. The crossover or no flow point. Each of these properties answers one of those important questions. Will this flow properly in my part? How long will this take to flow? How long before we can move our potted units? The portion of the graph that answers these questions are as follows. First, understanding where the lowest point of the loss modulus occurs tells us the optimum time you have to dispense the potting compound into your part. For the potting compound in this graph, we define this as where the material has a storage modulus of less than 10 to the negative 5 megapascals. For this graph, it is the beginning portion of the graph up to 4 minutes. The next question, how long will the material flow, can be answered by taking the first derivative of the storage modulus. The first derivative tells us the rate of increase of the polymerization reaction. The peak of this graph is the fastest rate of polymerization and thus fastest rate reduction of flow, indicating the point where the flow of the potting compound becomes increasingly restricted. Lastly, the crossover point answers the question, when can we move our part? At this point, the elastic properties overtake the fluid properties, and we relate this to the no flow point in the reaction, which is the crossover point. Now, the question you have all been waiting for. How can we speed up our process? The rheometer also has the ability to model all of the above data at elevated temperature. This graph shows the same thermoset cured at 4 different temperatures. As you can see in the graph, higher temperatures yield shorter time to the crossover point. This table summarizes the time for each temperature to attain optimum flow, first derivative peak, and crossover time. As you increase the temperature to speed up your process, you also shorten your flow and process time to no flow. The rheometer is a vital tool to model the processing of your potting compound. The ability to preempt the questions regarding, will this flow properly in my part? How long will the material flow? And how long before we can move the potted units accelerates your process engineering and time to market. The added benefits of modeling your potting process utilizing an elevated temperature can drastically reduce cycle time, increase throughput, and reduce manufacturing space for a net result of lower production costs. Now that the rheometer has helped you to streamline your potting process, the thermal chamber can begin to give you a head start on your life testing. Thermoset potting compounds are by far the best environmental protection for an electronic application. Our in-house thermal chamber allows us to test your potted electronic parts at your specified extreme temperatures and humidity. Our thermal chamber has a large volume of over 6,000 cubic inches to accommodate a large range of part sizes up to 20 inches long. The chamber also has multiple shells to accommodate a large number of samples. The chamber has a temperature range of -70 to 180 degrees C and a humidity range of 15 to 95% relative humidity. The chamber can heat at a rate of 2.75 degrees C per minute and cool at a rate of 2.5 degrees C per minute. These parameters are then used to set up your desired testing protocol using the PLC control on the thermal chamber. For example, this graph shows a sample protocol with a start temperature of -25 degrees C and 15% relative humidity for 1 hour, followed by a ramp to 35 C over a period of 60 minutes and soak at 35 C and 30% relative humidity for 1 hour. followed by another increase to 50 degrees C in 30 minutes and soak at 50 C and 75% relative humidity for 8 hours, then drops the temp back to minus 20 C and 15% relative humidity over 60 minutes to restart the cycle. The chamber can be set to run any number of cycles, from 10 to 10,000. The chamber is also designed to allow for the units to be tethered to a power source or diagnostic monitoring to allow for live analysis of the units during the thermal cycle. The greatest benefit of the thermal chamber is its location here in the Epic Resins lab. With the ability to conduct prototype potting on site, your potting development can occur in our potting lab and parts can be transported 10 feet to our thermal chamber. Your prototypes can go from potting development to life testing in days, not months. This type of thermal chamber access can reduce your engineering team's workload and take months off your engineering schedule. You have optimized your potting process. You have run your potted parts through a gauntlet of environmental testing. Now you need to verify your post-potting success. Our FTIR microscope is a tremendous resource to investigate potting quality, potting anomalies, or potting contamination. First, FTIR stands for Fourier Transform Infrared and is an infrared spectra absorbance of the chemistry of a substance. The infrared spectrum absorbance of a substance is a sort of chemical fingerprint that yields information about the chemistry of that substance. For example, in this spectra, you can see the broad absorbance at approximately 3,500 inverse centimeters, which is characteristic of a hydroxyl peak of a polyol, or the sharp peak at approximately 3,000 inverse centimeters, which is characteristic of a methylene group of a plasticizer. Because molecules are made up of several different functional groups, the absorbance pattern of a specific molecule will be unique to that specific molecule. This is also true for mixtures of molecules, where the mixture will have a characteristic FTIR absorbance pattern based on the functional groups it contains. There are two primary methods that we utilize at Epic Resins to measure the infrared spectrum absorbance of a substance: ATR and ATR microscope. ATR stands for attenuated total reflectance. And ATR works by placing the substance you intend to analyze against a crystal energized by an IR laser. When an evanescence wave is produced by the laser light, it comes into contact with the sample and absorbs some of the IR energy, yielding a single absorbance spectrum. This spectrum is specific to the chemical functionality that came in contact with the ATR crystal. An ATR microscope uses the same crystal types and technology as a standard ATR FTIR, but instead of producing a single IR absorbance spectrum, it measures the IR spectrum absorbance on the surface in an array. This feature allows us to detect chemical differences on a surface. This is very useful when you need to determine the chemical variation of a surface. To demonstrate the utility of the ATR microscope, we have two projects to share with you today. The first is an electronic application where the customer was concerned that there may be variation in the polymer at different portions around a sensitive component in their application. We started the analysis by sectioning the parts to the desired region where the sensitive component contacts the potting compound. As can be seen in this image, the tan portion in the center is the sensitive component. The gray area around this is the potting compound. The customer was concerned with the regions marked 1 and 2 and wanted to determine if there was a difference in the potting compound in these areas. We analyzed a 100 by 100 micron square area in the regions labeled 1 and 2. These FTIR microscopic images show the array of the FTIR absorbance at these two regions. In looking at these microscopic images, we extracted the actual IR spectrum absorbance from these different regions. These are the IR absorbance spectra for regions 1 and 2. When we overlay the two IR spectra and measure the statistical correlation between the peaks, we find a 98% correlation between region 1 and region 2, indicating a high probability and minimal difference in the chemical functionality of the two regions. The second demonstration of the utility of the ATR microscope was an instance where a customer was observing inconsistency on the surface of their potting material at the completion of their curing process. The image here shows what the customer was observing. We again started this analysis by sectioning the potting compound in the suspect areas. Upon analysis, the following ATR microscope absorbance pattern was produced. You will probably notice the significant color variation in this example compared to the first example. This is because the ATR microscope uses color variation to visually show where there are significant variations in the FTIR spectrum. If we look at the spectrum of the pink areas, you can see at 2275 inverse centimeters, the absorbance is minimal. However, the spectrum of the blue dots show a distinct peak in this region. To compare these regions, we superimpose the spectrum absorbance of the blue dots onto the spectrum absorbance of the pink areas. You can see a distinctly different peak at 2275 inverse centimeters. This is a NCO functional group. NCO is the reactive component of the B side of this formula, and its presence in the FTIR shows that it is unreacted because it was not properly homogenized during the dispense process. In looking back at the FTIR array, the dots that are blue in the array are areas where the B side was not sufficiently mixed, and the pink regions are areas where sufficient mix was achieved. Upon sharing these results with the customer, they investigated their meter mix and dispense equipment and found that they had a partially plugged dispense head manifold, which was causing a lead lag condition during the dispensing shot. After completing necessary maintenance protocol to their equipment, we were able to re-verify their mixing process was correct. These are just two examples of the utility of the FTIR microscope. We have also assisted customers in identifying surface contamination, thermal degradation, excessive mold release, counterfeit thermoplastic case material, and many other proprietary investigations. The FTIR microscope is an indispensable tool to investigate post-potting anomalies. These three pieces of instrumentation are a tremendous resource and benefit to your engineering team partnering with Epic Resins. However, these three pieces of instrumentation are a very small part of our extensive research and development lab. Coupled with our 65 years of formulating and polymer solution development, Epic Resins is at the ready to support your engineering team to meet your next design and engineering goals.
Thank you, Joe. Epic Resins' technical team is able and ready to be an extension of your engineering team by utilizing our knowledge, experience, and instrumentation capabilities. Our philosophy is to listen to your needs and develop quality solutions to meet your challenges. We will formulate or provide a material to fit your specific or unique product. With over 100 years of combined experience, our team of seasoned chemists are ready to use our extensive testing equipment as well as meter mix dispense equipment to meet your engineering timelines. Our qualified technical sales team will partner with you to provide the right material. Thank you for attending this webinar, and please contact us with any questions.